So I get ready for this test, I go back over it again. And I start with the Greeks and what they thought everything's made of, and then the guy named Democritus, and go over some of the details. What Boyle? What's Robert Boyle? What's that all about? Oh, I don't remember anything about him. Well, then you're going to miss those questions. Oh, what about J.J. Thomson? Well, I don't. We've done it 4 times. Maybe you need to write it down. Write it down. Maybe that'll help you. Get that? And look for details there, and then that part of the test will be you'll be in good shape for there. All right, then we started talking about the world of mass and the world of charge. Remember that? Remember that? What kind of words do you associate with the world of mass? Think about an atom and the world of mass. What do you associate with that? Give me some words. It's a world of nucleus, isn't it? That's where almost all the mass is. What else? What other words have to do with the mass, the world of mass? Nucleus? Nucleons? Protons? No, not electrons. Protons and neutrons. What's another word? Go loud. Say it again. Isotopes, yes. What else? How about mass number? Is that there? Okay. Do you remember the 3 isotopes of hydrogen? Remember that was on the packet? Okay, do you think that might be on the test? Yes. You see that? All right, let's do the world of charge. What kind of, I forgot, world of mass. How about AMUs? What's AMUs? Okay, all right. What about the world of charge? Give me some words that go along with that. Electrons. Protons, because protons and electrons have to do with whether or not you're an ion. Oops, I gave another word. Ion. How about ion? Yes. How about protons? Yeah. How about what's a special word for a positive ion? Okay, it's on your handout sheet. I can show you. Anybody? Cation. Cation. What about a negative ion? Anion. So cation, if you draw the cation, the T with a plus sign, you remember that cation is a positive ion, right? All right. Then we had the grid game, okay? So here's a grid game from another class. This might be your class. I'm not sure if this is yours or not. It might be yours. Anyway, let's do one more grid game since we've done this, but I'm going to have 10 of those on there. If you got all 10 of those right, wouldn't that be good? I got 10 questions in a row right. That's always a good sign in a test. Let's do one. I think I'll do a mg plus 2, 20. Okay. All right, let's do this one. What do you do first? What's it called? What do I call them? The alwayses. What's always true about mg? Always. Atomic number is always 12, and protons? Okay, you see that? You do those first. You do those first, don't you? Now, I can do either one. Let's do the world of mass here. This isotope has a mass of 25. They don't all have a 25, but this one does, doesn't it? And that is a number of what? What's the mass number? A number of what? Okay, so that many things in the nucleus, and 12 of them are protons. What's that mean? All right, you see that? Now I'm done with the world of mass. Now, so the world of charge. Protons are positive, electrons are negative. So how can he have a +2 charge? He's got 12 pluses. He must have what? 10 negatives, right? So if you have 10 electrons, that'd be -10 and +12. What's that come out to be? Or another way of saying it is the positives are ahead by 2. The positives are ahead by 2, aren't they? And I have 12 positives, so I must have that. I would love to see you just completely annihilate that page and say that is easy. I know I had to take my time, but I'm not going to miss any of those. Well, the harder ones yesterday, and I think I called you up, and I called maybe Ben. What if I said you only had 1 proton? What would you do there? Well, you'd put 1 proton here, wouldn't you? Well, what does that mean?
Hydrogen.
What now? Hydrogen, yes. What else does it mean? Now, see, I went to the alwayses. I went to the alwayses right away, didn't I? Now, I only have 1 proton, so how many neutrons do I have? And I have no electrons too, but no neutrons, so what's the mass? What's the mass number? 1. And I have to put a 1 here, don't I? And then now let's look at the world of charge. I have no electrons, but I have 1 proton. What's that mean? 0. Plus 1 and 0 is what? Plus 1 and 0 is what? Plus 1, isn't it? Okay, that's how you do it. Isn't that right? You have 1 proton and no electrons. All right. Are you okay on that? Let's go back to the study sheet. Now, everything else, there are some what I call leftovers. There are some leftovers, and they're not difficult. We've done 90% of the test is done. 90% of what you need to know is done. You get that? But we do have things in the chapter that are leftovers. So I do need you to pay attention. If you want to use this sheet, you can, or you want to write notes. I don't know how you do that, all right? First thing I'm going to show you is that you should know the different parts of the periodic table. Okay, now, we had done this one other time. Okay, let's do it again. This row right here, all right? Oh, by the way, on the periodic table, these things here, these columns, these are called groups or families. So if you say, what family are you in? Or what group are you in? You'll say the noble gas family. You get that? Now, what do you call this whole thing here, this whole row? What do you call that? It's not called a group or family. What's it called? And this was in the book, but I know some of you are not reading the book. I understand that, but maybe you could, does anybody know what you call, there's 1 of them here, there's 2 here. There's actually a total of 7 of these on the periodic table. And they're called periods. So ready. What element is in period 3 and a noble gas? What noble gas is in period 3? Period 1, period 2, period 3. What noble gas is in period 3? Argon. What alkali metal is in period 2? Here's period 2, right? What alkali metal? What are these called? That's right here. What are these called? These are the alkali metals, aren't they? Look right here. Is the camera on? Okay. So what do you call this group of metals right here? Alkali metals. Okay. So what alkali metal is in period 2? Lithium. Okay. Now what do you call this column right here? Alkaline earth metals. Got that? Okay, what do you call this big square block? This big block. They have them color coded. See, they have a nice colored picture. What do you call this group of metals? Transition. The transition elements or transition metals. Same thing. Got that? That's pretty easy. Now, does anybody happen to know what you call these? No. Look in the book. No. Look in the book. The noble gases, okay? The noble gases are really important in chemistry, and they don't like to react with anybody, okay? And so these are the noble gases. Anybody know the name of this one? This column, this family. Halogens. Okay, now, the real periodic table, I see where number 57 is right here, right? The real periodic table, you cut this part right here and move all those elements way, way down there, and you stick both of these rows right there. And these are the elements that come right after lanthanum. So lanthanum would be here, and if you move all those down, the next one would be all of these. What do you call these that come after the element lanthanum? Now you can say it. Lanthanides. Now, this element comes right after what? What comes after actinium? What are you going to call these? Actinides. Now, take a look at this picture here, and look how they did it in color. They did in color, didn't they? Look, alkali metals, alkaline earth metals. What are these called? What's it say? Transition metals. And what are these called?
Noble gases.
Noble gases. And these? The halogens. And these, this guy comes right after lanthanum, so these are called the what? Lanthanides, and these are the actinides. Now, the reason you need to know that is, and those are some of the simpler questions, and when you do the practice test here, when you take that thing, remember you're not doing the odd questions this chapter, right? Because you're doing that? when you do some of those questions on the practice tests, it'll say, what transition metal has the atomic number of 26? Or it might say, what is that one? What transition metal, or what part of the periodic table is element number 26 in? What does it belong to? What would you say this belongs to? What group, part of the periodic table? Transition metals. Those are some of the easier questions. Now that's why I kept these to the end. This is not hard. You just have to, you do it a couple times, you say, oh, that's going to be easy. All right, let's go back over. What else is on the test? And so I'm going to turn the page here. Does everybody know where the metals are and the non-metals? Does everybody know that? Let's try that. See this little stair step here. See that? See that little stair step? Okay. Now, not counting hydrogen, okay? See how it's separated? Anybody who's below that stair step, all these, metals, yeah? There's a lot of metals on the periodic table. Look at this picture. See how they color-coded it? Where are the non-metals? Right here, right? And including hydrogen, right? Is that the non-metals? Now, look right here. Not counting boron, he's clearly a non-metal, and aluminum is clearly a metal. But anybody else who's right along the stair step, silicon, germanium, arsenic, antimony, tellurium, see those? If they're right along the stair step, they have the tendency to be kind of like a metal and kind of like a non-metal. What do we call those? What do you think? Okay, metalloids, right? I like the other name. In England, they don't say metalloids, they call them semi-metals. I like that word. And you know why I like that word? Because one of the biggest industries in the United States is in California. And they make a whole lot of stuff with a metalloid or a semi-metal, and it's called Silicon Valley. Silicon Valley makes computer chips. And computer chips are things that you can make them either conduct electricity or not, and they act like switches. And that's where all the memory stuff comes from a computer, is these computer chips. And so I like semi-metals because you can make semiconductors out of them. It's the semiconductor industry. Yes? Okay. All right. So now, pretty easy. These are leftovers. Now, here's something it's really a lot easier than you think. God, he has all these little building blocks here, and that's okay. I'm really glad he had, but that's only 100 now. That's not very many building blocks. But he even made some of these building blocks had more than one form to them. Now, for example, if I had a balloon here, and it had helium in it, and if I could shrink myself down to the size of an atom, you know what I'd see? A helium and a helium and a helium and a helium and a helium. And that's what I'd see in that balloon. But what if I had a balloon full of oxygen? What would I see there? This might surprise you. I'd see O connected to O, O2, two O's, two O's, two O's, two O's. And the fancy name for that is it's a diatomic element. So it's a diatomic element, and God made a few of those. Now I'm going to show you a little memory trick to tell you which ones are diatomic elements on the planet. Okay, it's the ones that end in gin. Their name ends in gin, G-E-N. So give me an element that ends in gin. So if I had a balloon of hydrogen, what would be in that balloon? Not H, 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 H. What would be in there? Not H2O, but leave out the O. H2, H2, H2. It'd be two H's together, wouldn't it? And it's a diatomic. What's di mean? Two atoms of the same kind. So, does anybody know what's another one that ends in gin? So hydrogen is a diatomic element. Oxygen. Another one? Nitrogen. Does anybody know what air is made of? Air is almost 80% nitrogen. But what form is it in? When I breathe in, is it N or is it N2? It's N2. It's a diatomic element. What else do you breathe in? What's 20% of the air? And what are you breathing in? O or O2? O2. Yes? I'm looking at your faces, all right? I know it's the last period there, isn't it? Is that right? I know that. All right, so what do you breathe in? You breathe in O2, don't you? Now, what are the other elements that are diatomic? That's the good news. They all end in I-N-E, and they're all found in the same group or family. It's the halogens. So if you gave me a balloon full of fluorine, it would be F2, 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 F2. All right, fluorine is diatomic, F2. Chlorine, Cl2. Bromine, Br2. Iodine, I2. So the question I would ask on the test would be, list 5 of the 7 diatomic elements. The formulas. So what are they? Help me out. What would you write? Here you go. What would you write? O2, oxygen, nitrogen, hydrogen, and what about the enes? Chlorine, fluorine, bromine. See that? And I wrote 2 here because what's that little subscript mean? It means there's how many chlorines are here? How many chlorines are in this thing? 2. What does it mean when you write H2O? It means 2 hydrogens and what? And they never write the 1. They never do write the 1. It's really H2O1, isn't it? Okay. You see how I call these leftovers? These are leftovers, all right? Now, let's go to the next leftover. There's a word in here, and I circled and everything. It sounds like a word we had before, but it's not the same word. When I say the word isotope, aren't you messing with the nucleus of some atom? And you put some extra neutrons in there, and it becomes heavier, isotope. You take some neutrons away, and it's the same element, but it becomes lighter. And those are isotopes, aren't they? What's this word? Allotropes. Now, I know it's a vocabulary word, but what's kind of neat is, here's what God did. God said, I'm going to do something else. I'm going to make some more variety. Remember I talked about the diatomic elements? Did you know the oxygen can come in this form here? That's what you breathe. See this here? I breathe this. But there's another form of oxygen called O3, and you call it ozone. You don't want to breathe that. Matter of fact, big cities, I know LA, I've been to LA before. LA happens to be sort of in a valley, like that. And when there's no wind, and day after day they have all that pollution and stuff from the city, you get a lot of ozone. And the ozone builds up in that little valley. And they tell people, stay indoors. If you're having breathing problems or you're older, stay indoors. They have these things called ozone alerts. It's not good to go out and breathe heavy ozone layers. Now, they hope that a storm's going to come in with some wind and put some new air in the valley, and then they can go out again like that. So ozone's not a great thing, but these are different forms of oxygen, O2 and O3, diatomic and triatomic. And these are called allotropes here. Now the one I'm going to probably ask you about on the test, I'll even give it away, is the allotropes of carbon. Okay, here are the allotropes of carbon. If you have C, just plain old carbon atoms, or even diatomic carbon, if you have C or C2, you saw that when you did the candle experiment. And what form of carbon was that? That was soot. Black, powdery, stuff like that. Get that? Let's turn the page. There's another form. Another allotrope of carbon is found right here. That's not a very good pencil. Okay. Here's one right here. It's called graphite. I know you think this is lead. They've never put lead in pencils. It's carbon. Now, graphite is carbon that is bonded really well this way in plates, but almost no bonding occurs up and down. And I still remember this long time ago, and I was so fascinated when somebody told me that when you write something on a piece of paper with a pencil, you know what's happening? These sheets of graphite are going, and they're just coming off the pencil, just like little shingles coming off like that. And I always thought that was interesting. And not only is graphite dry, it's dry, but it's a different form of carbon. And I've even done this before. I don't know if you ever had a lock that was hard to open. It's kind of, you had to wiggle things, and it's kind of rough. You can actually go to a store, and I know what you might say, I'll put some oil in that lock. Well, I had a car once, I had trouble opening it, right? I could put oil in that lock, but every time I put the key in there, wouldn't the key get oil on it? And then I put it in my pocket? So what do? I go to the hardware store, and you can buy a little bottle of graphite. Now, why would I want to put this powdery stuff in that lock? Because you know what happens? When you put it in there, the one piece of graphite slides right past the other, and it's very slippery. You put the graphite in there, all of a sudden, oh man, the key opens it really, the lock worked really, really well. How many of you have ever used graphite before? Really? Okay. Anyway, it's a real slippery material. Now, that is another allotrope of carbon. So soot is an allotrope of carbon. Graphite is an allotrope of carbon. And let's talk about another one. Most people do not know that if you take carbon and bond it really tightly this way, and you bond it in the other direction, all three dimensions, you have the hardest material on the planet. What's that? Diamonds. Most people have no idea that a diamond is carbon. And that's another allotrope of carbon. And one more. See this guy right here? I'm right here. I'm in a model. They didn't discover this until about maybe 20 years ago. And they actually found them in candle flames. This is a nanoparticle. This nanoparticle is C60. There's 60 carbon atoms together that make this weird little ball. You get that? Now, when they discovered this thing, they could have named it after a scientist. But you know what they decided to do? They decided to name it after an architect. He said, architect? Why would you do that? There was a guy, and let's see if his name's in here somewhere. His name is Buckminster Fuller. Now, what he did was, he's the first person to design what they call the geodesic dome. Have you ever seen a geodesic dome? Have you ever been to Disney World? Epcot, that ball is a geodesic dome. It's a bunch of hexagons and pentagons and things like that. And he had designed buildings made a geodesic dome. Well, the scientists thought, what a great tribute to Buckminster Fuller to name this after him. And so they called it a Buckminster Fullerene. Now, nobody likes to say that, so they call it a buckyball. See this? So if you want to look up nanoparticles, I'll give you extra credit for that. You look up Buckminster Fullerenes or buckyballs. Find out what they're doing with these, because scientists have figured out what to do with them. They discovered them. Now they know what to do with them. All right. So what are the four forms, the four allotropes of carbon? What is it? Sorry, what's one of them? What is it? Soot. What is it? Graphite. Diamond. And buckyball. Okay? Now, you understand, the reason I call these leftovers is I don't need to spend day after day on these. These are little things in the chapter. Yes? Yeah, okay. All right. I think what I might do is I might make this last 2 pages, I might make that an extra credit question. So I think right now we might have had enough, as far as enough for you to study for a test. But if you were to read the last 3 pages, some bonus questions will be on that, okay? So if you feel like you want to do that, you want to get some bonus questions right, you can. Otherwise, you might have to. There you go. Oops, frozen. Okay, so here's what we're going to do, right? I'm going to stop, and what you're going to do is you're going to get in little groups, and you're going to take this sheet, this packet I gave you, and if you feel like your study group, if you just want to study things, you can do that. This is a review sheet. See that? And these are some people. That's somebody. A student made that. Let's take a look at the next one. Now, what you want to do is you want to fill this out. Like, for example, excuse me. Sorry. See this one here. This is matching. Is also known as Lord Kelvin. Which one is that? What letter would you put next to that? Who's also known as Lord Kelvin? William Thomson. Okay. So anyway, you guys can go through these. I want you to sit in a group, and what I'll do, I'd be willing to do this. You have the rest of the period today, and I'm gonna walk around and help you if you need help, and you have all period tomorrow. Okay? So there really is no reason why you can't get ready for this test. All right, find a table. I'll get my stuff off of there. So if you want to get your own group there,